Welcome to the special program on NEWS9. A Bengaluru scientist claims that he has found an alternative source to costly LPG. All he needs is water, cooking oil and some sunlight. Take a look.
This machine might hold the key to solving the domestic energy crisis, and this man could go down in history as the man who brought change through his out-of-box thinking of simple science. Dr. Raja Vijay Kumar has been able to make science fiction a science reality. The LPG gas made from his contraption requires distilled water, cooking oil and sunlight channeled through solar panels. The machine helps in generating LPG without any petroleum products. The water that passes through this hydro decider creates nascent oxygen and hydrogen. This is due to the reaction of water with platinum and palladium rods. The nascent oxygen and hydrogen is mixed with cooking oil under high pressure in a compression chamber, which gives the byproduct that can be used as cooking gas.
See, I'm typically taking about 14 liters of 14 kgs of LPG. If you take the calorific value and then work it out, it will come to approximately 3 to 4 liters of water, about half a kg of oil, and about 5 hours of sunlight. And that is what is required. That is enough for the 1 month's need of cooking gas.
The LPG that is made from petroleum has 3 varieties, but the LPG generated through Dr. Vijay Kumar's machine has 8 varieties. The flame temperature is also higher than the normal LPG. It took this scientist 6 years to achieve success and has now registered his invention for patents.
The R&D for this particular project of recovering hydrocarbons from non-hydrocarbon sources started about 5 to 6 years back. Okay. There were many attempts done on this particular project. A lot of failures were there, but every failure is a stepping stone for success in Heldange. We have succeeded finally to recover hydrocarbons from non-hydrocarbon sources. Now you see the result of it. Okay, it's a very, very good result that we have got, which will be very useful for all human mankind.
Dr. Vijay Kumar plans to market his invention within the next 6 months. He says he's ready to face any sort of questions regarding his invention. He believes his invention will help India solve the energy crisis. Maltesh for NEWS9, Bengaluru.
So the question that we are asking here is, would you use Dr. Vijay Kumar's invention when it hits the market? Share your views with us. Call us on 080-22360304 or 05 or SMS as at 99809-45138. So it is very interesting about this invention. So let me introduce this guests who are here. We have T.G. Sudhakar, the director from Analytical Research and Metallurgical Lab Pvt.Ltd. We have the inventor of this contraption, Dr. Raja Vijay Kumar, who is the chairman and chief scientific officer. We have Basavaraj, the technical officer of Karnataka State Biofuel Board. In fact, sir, coming to you, the inventor, I would like to know, it was an accident that led to this particular invention, wasn't it?
Yes. To begin with, it was an accident. In fact, we were actually not working on this 6 years ago, but we were working on something else which we call it a superconductor capacitor, and we were using platinum, palladium, and graphene, which we produce in our laboratory, and so on. So it was started off there, and we had used sesame seed oil as sealant in one of the experiments, and we found we observed something very strange in it, and we found that there is something which we couldn't account for. So in the last few years, we've been working on it to try and replicate what we saw. So it took us a long time trying to replicate what we actually observed at the first time, and and slowly we could get to the crux of it, where after a large number of attempts, we could finally hit on the right kind of conditions, which originally happened by accident. And then we could build the reactors.
So it was the smell that came from the gingerly oil.
Exactly.
Something that was in your original experiment did not actually
Yeah.
play a very big role, but something that was minor that caught your attention.
Yes, yes, yes. It was, you see, sometimes it so happened that you expect something to happen when you do something because with your known knowledge. Sometimes when you are experimenting with something, few things happen which is beyond your known knowledge. So when it happens beyond your known knowledge, first thing which comes into your mind is confusion. And second is you start blaming yourself and everybody around that something went wrong. Okay, and if you can't get to where whom to blame, then finally you come to a situation where you start thinking about it. So that is where we started thinking about it, and we did many attempts, and then finally we could come to the I would say the right kind of environment, right kind of situation where probably that was what is the situation in the first place. And then we could find the reason why it was happening.
So basically it was curiosity that drove you. What created the failure in your first experiment? That curiosity drove to find out what
actually
exactly
the first experiment was not a failure.
Okay.
It was only that we observed
something not that's supposed to be there.
Yeah, supposed to be there.
So it was the scientific curiosity that led you to invent something like this.
Of course.
Okay. And how does this process work? In fact, for layman's term, for me it is just cooking oil plus water plus some sunlight that is required. So can you explain to us in those terms?
It is like this. We have a reactor here, okay, which we call it as the hydro decider. And this reactor actually produces a special kind of hydrogen and a special kind of oxygen. I'll come to why it is special kind of hydrogen and oxygen. Normally, if you take water and electrolyze it, you put 2 electrodes into it and pass current through that. I mean, there's a high school experiment which most of us have done, where you get hydrogen and oxygen, because that's what water is made out of. Now, hydrogen is a whole molecule, H2, and oxygen is a whole molecule, O2. Now, this hydrogen and oxygen, we all know water consists of this, and when you electrolyze, you get this. But these are very explosive. Hydrogen is a very explosive gas, and it makes a huge explosive sound, and it can explode. It's a very dangerous stuff. But in this reactor, what I'm talking about is you have a special type of catalyst.
You call it the hydrogen decider.
Hydro decider.
Hydro decider.
Okay. It's a hydros for water.
Okay.
D stands for disambiguity.
Okay.
Means newborn.
Okay. You have made. Okay. You've given the name for this reactor.
Exactly.
Okay.
So it's disambiguative catalytic donor recombination reactor.
Okay.
So that is what comes as
hydro decider. Okay.
Okay. Hydro is water and decider is the reactor. Okay. So coming back to this, in this reactor you have specialized catalysts. So these are made out of platinum and palladium. They are noble metals, very expensive metals, and they are catalysts in many different chemical reactions. It's already there in many reactions. But in a particular combination of this, okay, it seems to break the water into nascent hydrogen, N minus, I would say N plus and O minus.
Okay. Okay,
and this goes through a secondary reactor where you have a catalyst, which is basically an arsenic complex catalyst, which sustains the H and the O. H plus and O minus for a longer time, because they are very highly reactive, and let alone they either form hydrogen and oxygen or they form water again.
So then this is sent and it is compressed with.
Now it is first made to sustain.
Okay.
So you have to sustain it, and this is guided through a special pipeline. Okay, that is specially handled with electrostatic charge, so they never come to each other. Okay. They are within the same room, but they don't talk to each other. Let's put it that way.
That way. Okay.
Okay. And then this is plunged at a great velocity into a carbon donor reactor, which contains the oil. Okay. Now this is plunged into the oil at a very high velocity. That's about 400 to 600 kilometers per hour. That kind of a speed. it is plunged into it. Now, what happens here? Okay, all these are our hypothesis. What's happening?
Okay.
So what happens here is, we all know oxygen. Nascent oxygen is an excellent bond breaker.
Okay.
Okay, it's found in outer space, not very common on the planet, and it's a great bond breaker.
Okay.
And hydrogen, on the other side, is a great bond maker.
Okay.
Okay, so
basically the CH bonds that you're looking at,
yeah,
which is
the
present in the
oil is
hydrocarbon.
nothing. Oil is nothing but again carbon and hydrogen and
hydrogen.
Maybe oxygen and nitrogen and other substances. But then the oxygen, nascent oxygen, breaks the bonds which are in the
carbon hydrogen combined.
Okay,
that's already there
in the oil, and the nascent hydrogen forms new bonds.
Okay.
And it is in nature itself, when a carbon hydrogen bond is formed, in nature itself, it starts forming from C1.
Okay.
So C1, C2, C3, C4, it forms forming in that fashion. It's nature's job. And finally, in this reaction, you could get C1 to C8, that is from methane to octane. Okay. Interestingly, we found that a used cooking oil, which is already boiled and heated and so on, maybe because the bonds are weaker, you get more of smaller molecules like methane and ethane. While in the fresher ones, you get more of heavier hydrocarbons. So this is what we observed, and once we saw this, we found that the gas burns. So when the gas is burning, it was nice, and we had to be very sure, because see, we are working at very dangerous levels. That is, you can also be producing hydrogen, and that can probably explode our entire laboratory. So you have to be very careful on that. So we had sensors for it, and all that. And once we had the entire gas ready and burning in a special burner, it was a special burner, then we sent the gas to third-party laboratory analysis, and to see
that
whether
is the Eureka moment. That's your Eureka moment.
That we knew that there was a kind of a inflammable gas, but then we don't know what it is. It could be whatever gas.
So anyway, hold on, Doctor. We will come back to you. We'll go into a small break now, and we'll later discuss how that Eureka moment came in when he in fact sent those gas samples for testing. Welcome back. Well, we were asking, would you use Dr. Vijay Kumar's invention when it hits the market? It's a very interesting invention. In fact, share your views with us. Call us on the numbers that are flashing on your screen. So, Dr. Vijay Kumar, you were saying you had sent the samples for testing, and what was the result at the end?
Okay, now we had, by the time, tried out different kinds of oils, edible ones, non-edible ones. We've tried out, used one, mixture of these cocktails, and so on. So then we sent these samples, first of samples to ARML, and they tested, and then the results which came out was totally unbelievable. I mean,
so here is a story about something going strange in the first experiment. You were curious enough to find out something had to be done about it. So your findings reach a lab, and now they give you more of a surprise.
More of a surprise.
Okay.
Yes.
Okay.
So then the results which we got, we called the lab and asked them also that, are you sure that this is what you have seen?
They themselves couldn't believe what
they themselves couldn't believe, and of course they were just testing a sample. So it is not that they just tested it, gave the reports to us, and then we called them up and asked whether, are you sure about this, or are you mixed up with somebody else's samples? Okay, so
it was unbelievable.
It is unbelievable. See, we know that it is an hydrocarbon, but then we never knew that it had
similar components
such
like
a
LPG,
huge range of hydrocarbons. Okay, and that was a surprise. And then we sent number of samples after that from each oil. Practically every second day they used to collect the samples, and so we tested it a number of times, and we used gas chromatography, which is considered to be a gold standard in gas analysis, and we even blinded them that we sent gases.
So every moment you were not willing to believe. You wanted to. was it that doubting Thomas moment, like, you know, you've seen it, but it's yet to set in, saying that you've actually stepped on something?
See, absolutely, it's very important. See, when you are going to talk about or tell that something so sensitive like you know, making hydrocarbons from non-hydrocarbon, you know, I should not become a fool after that.
Okay.
You know, so I should be extremely careful to see what I am going to declare or what I am going to tell or talk about. So we had even instances where you know, we just have little small quantity of gas and fill it up with air and send it to the laboratory, okay, to see if their laboratory tests would really be you know, can be believed.
So that was your unbelievable moment. I'll get Basavaraj, who is the technical officer with Karnataka State Biofuel Board. When you heard about this, what was your first reaction? Gingerly oil, sunlight, water, you're getting something of a huge range of hydrocarbons that can actually be put into use as cooking gas. That is normal, and probably beyond that also. What was your first reaction? Was it possible?
First of all, as it was a surprise for him, I say all the great inventions have come by that route only. So probably this is also one among those kinds of inventions, etc. And really such technologies which a country like India or elsewhere in the world, we are looking those kinds of technologies. But now really it seems to be a future technology, and for a country like India, and you see our spending on the LPG, etc. Every year,
yeah, it's got a huge implication. Economically, it's got a huge implication.
400 crores of rupees we are spending for the fuel purpose only, LPG only. So, and we are not in a position to fully meet our energy demand also. So, in this LPG only, we are importing around 20% of our requirement needs to be met by imports, for which we used to pay foreign exchange. So all those things can be some sort of relief for the country, as well as this is a technology which uses the renewable source of energy. Okay. So that is the other advantage what I can put it. Yes. Yeah. So the technology is indigenous technology and environment friendly technology, and we can say foreign exchange.
But when you heard this,
probably
when you heard this, what was your reaction?
So even we are also surprised to.
So basically, everyone is in a moment of shock and awe at the same time.
Yeah.
Okay.
So definitely, probably we will have to, when we think of taking these kinds of technologies to the people, then probably we will have to work on those issues also.
We have a caller now, Udit from Kathirakoppe. Udit, you can go ahead with your queries.
Yeah, can I speak to the doctor over there?
Yeah, you can speak to Vijay Kumar.
Good evening, sir.
Good evening.
Sir, it's a basic principle in science that how many ever times you convert energy, there are going to be energy losses. And from what I can see in the visuals, that's a luminous flame. So how is it energy efficient, sir?
Here it is, we are here talking in terms of producing, you know, petroleum hydrocarbons from non-petroleum sources. Now, I don't say that you know, it is something which is producing more energy than what is put in. You know, what the device does is to use sunlight as an energy source to produce in a special reactor the nascent hydrogen and oxygen required, and then use that in a process of converting you know, cooking oil or non-cooking oils, in the sense vegetable produce oils, into gases. Gases which is ranging between C1, C8 and the hydrocarbon chain.
So again, but we'll be using electricity produced from coal to hydrolyze water, sir. I think it's extremely energy inefficient, sir.
No, we are not producing energy for this device. We are not producing energy from coal. We are producing energy from the sunlight.
Oh,
Okay, and even if it is
And
produced
that's
from
a good idea, sir.
yeah, even if it is produced from from the grid, even then it is here to sort out a problem of hydrocarbon. Okay, not the problem of how much energy you consume. But incidentally, since you called me and asked this question, the whole device works at the moment at 86% efficiency.
Oh, that's
Well, I think
Thank
it
you.
answers your queries, Udit. Sudhakar, I would like to know what was your reaction when you heard there was a simple process to create those elements that are normally found from petroleum, as he said, from non-hydrocarbon sources to hydrocarbon sources. Was it science fiction coming a reality in front of you?
Yeah, definitely, because we don't know what is the actual this thing composition. Okay, this is a new discovery, whatever has been happened. After the injection into the particular gas chromatograph, we came to know these are the gaseous hydrocarbons present in that particular unit. So I was shocked. Then we repeated twice. Then it is of same results. I was wondering because initially we used to get the lower hydrocarbons as major, and the heat of the particular thing is more.
Okay.
So that is the main thing, and keep on going with the different trials. We are finding different composition of the hydrocarbons, in the different ratio.
Is there a scientific orthodoxy saying that you can't get hydrocarbons from non-hydrocarbon sources? Did it break that scientific orthodoxy?
Yeah, actually, strictly speaking, seeing that hydrogen H plus and OH minus, but the technique what doctor has been used is entirely different.
So
It's
you
new technique.
You were
We
thinking
too.
out of the box. I mean, the
Yes.
doctor thought out of the box,
Yes.
not from what has been taught to him. You went beyond the boundaries.
Yes, yes.
How was that experience, in fact, going beyond the boundaries when, as you rightly once said, that you have to say something that makes sense, so you have to go against scientific orthodoxy, so you don't want to sound like a heretic, but saying that you're within the limits. How was that conflict played around with you?
Well, that's the first conflict that is very, very hard to negate. When you come to see something which is not in the present science, and it's something which is beyond your knowledge or perception, is something which is very difficult for you to it really puts you off without sleep for days. Okay, and but then you finally reconcile, then you start thinking, then you start making hypotheses that this may be possible, that may be possible. That's how you go about it. As of now, there is, as I know, by literature searches and so on, and also for searching when we were going to register the patent. So we found that there is no similar thought process which has been there before.
Because what I know is, like, during World War II, when Nazi Germany was facing a petroleum shortage, they had coal converted to petroleum, but they had a coal as a product.
Yeah,
it was not
See,
a vegetable oil.
even there, there was a lot done during the World War II because of acute shortage of fuel, and it was most of the time converting a lower grade petroleum product like coal or lignite and so on into higher grade petroleum product. Okay, it was not. It is not as of today that anybody has done, wherein you take a totally non-petroleum product, you take a plant product, you take a vegetable product, and then make it into a petroleum hydrocarbon. Now, if you take the composition of this, we have almost, I think, about 8 to 10% of octane in this.
Okay.
Octane is nothing but a petrol, actually. It's am I right? It's petrol. Okay, high grade petrol. Okay, now if we would moderately pressurize it, reduce the temperature, the whole thing is liquid for me.
Okay.
I mean, that is what that's why I say LPG is liquid. Now, a large part of that liquid, okay, is about 10% of the liquid is petrol. Okay, and if I fractionally distill it, I should be able to get petrol out of it.
We have one more caller. We have Shruti from Hyderabad. Prithvi from Hyderabad. He has some queries. Prithvi, go ahead. What is the queries that you have?
Sir, I want to ask the cooking oil that we use now. It's also very costly. It's not cheap, and it's around 500 rupees for 5 liters that we're getting the can. So, is the gas that's coming out? It's also going to be costly, and can it beat the LPG that's available as a cylinder outside for 700 rupees per cylinder? Is it economically viable?
So again, that is the question I think you have to answer.
First of all, I should tell you, it is not 5 liters of oil, it's 500 grams of oil for the whole month of cooking gas. Okay. So 500 grams of oil costs about 30 rupees or so, 35 rupees. So it's the expense is 35 rupees for the whole month of cooking gas. It's not 5 liters.
Okay, thank you, sir.
So again, coming to it, gingerly oil. Why gingerly oil? Because even in the visuals we saw gingerly oil. What is the
no, actually, let me tell you, it is because we had gingerly oil in our cafeteria, in our canteen.
Okay. So what was locally available is what you mean.
Exactly. Okay. And the thing is that we started off with gingerly oil because in the accidental thing which happened first, okay, at that time we had used sesame seed, that's gingerly oil. We had used it as a sealant. Okay. So then it's better to start with a known devil, you know.
Yeah. So that you can replicate the same conditions.
Exactly. So and not only that, we had this oil in our it was available in the canteen. So that is how we started off with.
So, sir, Basuraj, I want to ask this question, like when some technology like this comes, it is very rarely seen that the government supports it because there's a lot of queries that come in, and then so he's planning to introduce this into the market in probably I think 6 months to 1 year. So he's planning to introduce. We have tried with biofuels. We didn't succeed the way that we should have been able to, taking, as you rightly pointed out, taking that pressure away from our economic expenses that we had with the petroleum products that we are importing, but we didn't succeed. In this case, do you see that possibility of succeeding in the market? Because already solar panels are used in your his technology. We already have solar panels for heating water and other things. So this could be a part of day-to-day kitchens, a contraption that is required in the kitchen. So do you see that kind of success coming with this product?
Yeah, definitely. We are finding, we are solving the energy shortage or energy crisis by various ways. So biofuels was also one among the ways where it addresses the alternative fuels. Apart from that one, it has got its own different advantages in rural area. That is the different route. And what has been addressed here, it is the LPG. Here also there are certain issues comes, safety parameter comes whenever it is being used. Whenever it is being used, even in LPG also the lot of safety parameters.
How do you concern with safety? Because you yourself said.
Second thing, storage. So how it needs to be storage parameters. So in case if it is considered as an explosive material, then explosive safety norms are quite different. There are some regulatory issues, there are some safety parameters, and even somebody was asking use of edible oil for the production of fuel. So national biofuel policy as well as the Karnataka state biofuel development policy also states that so use of cooking oil for the production of fuel is banned actually. So once if we start to use using this cooking oil, so shortage of cooking oil will come.
We have one caller, in fact, who's joining us, Kiran from Vidyaranyapura. Kiran, what is the queries that you have?
Yeah, sir. I wanted to ask Mr. Vijay Kumar. I have two queries to make.
Go ahead.
Regarding how is it different? Actually, from what I've heard, combustion happens. When combustion happens, water is produced. But what is happening here is the reverse process. He's putting in the water and then he's producing the water. How it is all happening? I wanted to know about that.
In fact, we had discussed about that entire process that is happening here. In fact, Dr. Vijay Kumar had spoke about it. He had in fact said that there is a hydrodecide reactor in which it produces nascent hydrogen and oxygen, which reacts later with the oil, and there's a lot of bond breaking and formation that takes place because of it. So he had already spoken about it. What is your second query?
We have seen that biodiesel is almost becoming common. In the future, biodiesel is nothing but they're using the extractor from the seeds of various vegetables, and how is it different from this vanaspati what is using here?
So can you give a short answer to that question?
So in case what we are using as per our law, we are using only non-edible tree-based oil seeds.
Okay.
tree-borne oilseeds what we are using. The Pangemia pinnata is there, neem is there, mahua is there, semarva is there, like that. We have identified 150 types of tree-based tree-borne oilseeds. So from every seed we can produce oil, and all the non-edible oil seeds, whatever we are producing, we are extracting the oil and converting it to biodiesel, and we are using biodiesel in one way as fuel. The other way, the oil cake which is going to be produced there, it goes as organic manure to the same field where it has been.
So that I think answers the queries well. That's all for this edition in this discussion. We have a news bulletin next, but till then it's goodbye from this program.